And this brings us straight to the concept of centripetal acceleration. But before we do that, let's just make sure we can be able to visualize how this looks. Okay, if we have a circular path and the center of the circular path is O, okay, and this object is transitioning from A maybe to B, okay, and tangentially to it there's a velocity vector. Same here, velocity vector. Okay, this is linear speed or linear velocity. This is linear speed or linear velocity. In the middle here is angular displacement. Okay, the centripetal force acts inwards. Okay, it acts inwards. You'll notice this, that when someone is running in a circular path, they lean inward so that the component of their weight can be acting inward inside the circular path. Okay, so the force vector acts inwards. That's how the centripetal force points. Okay, and is perpendicular to the velocity vector, the linear speed. All right, so that's how the centripetal force acts. Okay, at the same time, the acceleration also takes the same direction as the force, centripetal force. So the acceleration will also be pointing towards the center as AC. Okay, now let's define what centripetal acceleration is so that it makes sense. Now, what you'll notice is that we're dealing with uniform circular motion. Okay, we're saying uniform. What does it tell us? It means that magnitude of velocity doesn't change. So the magnitude of velocity remains the same. But what you will see is that we said, but the direction keeps changing. Okay, now I want you to understand something. When you're dealing with vectors, we say vectors are quantities that possess both magnitude and direction. Okay, there are two ways that velocity can change. First of all, now velocity is a vector. Okay, that means it has direction and it has magnitude. Okay, there are two ways velocity can change. The first way is to change the magnitude. That means you say 5 kilometers per hour and then it changes to 6 kilometers per hour. Okay, this is not the same as that. Reason is because the magnitude of the velocity vector has changed. All right, the other way, however, is to change the direction. Okay, so you may have 5 kilometers per hour east and 5 kilometers per hour north. These two are also not the same. They may have the same magnitude and you may say the speed is the same. When I was going to Karonga, the speed was the same. When I was going to Sanje, the speed was the same. But because the direction is different, the velocity wasn't the same. Okay, the velocity was not the same. Okay, so what you have to understand is, as we are experiencing uniform circular motion, the speed, which is the magnitude, remains the same, but the velocity, okay, let me just make sure I do this properly so that you really understand me here. Okay, the speed remains the same. How? In magnitude. Okay, but velocity changes. How? Direction is always changing as the object moves in a circular path. Okay, so the direction is always different. Okay, you can see here it's pointing this side, that time is pointing that side, another time it will be pointing that side, but the magnitude is the same, only that the direction is different. And you have to understand that acceleration, okay, understand that acceleration is change in velocity over time. Okay, so how is the velocity changing in uniform circular motion for us to have centripetal acceleration? What you have to understand is centripetal acceleration does not come because velocity changes in magnitude. No, it comes because velocity changes in direction. So it's an acceleration that is experienced not because the magnitude of the velocity is different. It's simply experienced because the direction of the velocity vector is always changing. So you will not see an object experiencing uniform circular motion speeding up, okay, meaning the speed increasing every time in terms of magnitude. No, what you will see is that it will have a constant change in direction. That constant change in direction is what brings about the centripetal acceleration. Remember, this change in velocity in the centripetal acceleration is not due to the change in magnitude of the velocity, but in the direction of the velocity. And that's what institutes centripetal acceleration. That is very important for you to remember. Very, very important. Okay. Very, very important. Now, let's make sure we clarify something. Okay. This. I hope this will be very helpful to you. Remember this. Okay. Now, the next thing I want us to understand is that I think we remember this from the second law of motion. We said, second law of motion says force is a product of mass and acceleration. This we remember this, okay? And if we look at the formula for centripetal acceleration, okay, but according to the second law of motion, F equals ma. Therefore, Fc will be equal to mass times v squared over r. What you notice is that the mass here is the mass there. Okay, if force is equal to mass times acceleration, it means this remaining part must be the centripetal acceleration. So this will become F times AC, because according to the second law of motion, force must be equal to mass times the object's acceleration. So since we're dealing with circular motion, it means this part of the centripetal force formula must be the centripetal acceleration. Okay, this means AC is equal to v squared over r. Okay, those are the two formulas that we must keep. First formula and second formula. All right, that's very important. I hope you're able to understand this. Okay, I want to see questions in the comment section if you don't understand something, so that I can clarify it in the next lessons. But otherwise, let's transition now to the final part of the lesson. Okay, that is calculations. This is gonna be fun. Okay, this is gonna be fun. All right, I want you to really see this. All right, now first thing we need to remember that centripetal force is equal to mass times v squared over r. Centripetal acceleration is the v squared over r. Okay, so this is not many formulas, it's just a few, two of them. Now they're telling us here that mass, a 5 kg mass in the first example, mass moves at uniform speed of 18 meters per second in a circular path of radius 0.5 meters. Okay, then they're saying calculate the centripetal force acting on the mass. Okay, so we know we're given mass which is equal to 5 kgs, and we're given the linear speed. Now they're saying it's uniform speed, 18 meters per second, and the radius as 0.5 meters. Okay, therefore the centripetal force will be equal to mv squared over r, which means it's 5 kgs. 5 kgs multiplied by 18 meters per second squared multiplied by 0. Oh no, let me remove this. Okay, divided by let me just use a straight line. Okay, divided by 0.5 meters. That gives us so we have 5 kgs multiplied by 18 squared. That gives us 1000 620 kg meter squared per second squared, divide by 0.5 meters. This gives us divide by 0.5. This gives us, this can cancel with 1 there. This gives us 3,240 newtons. All right, so that is the kg meter per second squared is newtons. All right, so that's the answer that we're supposed to find. Okay, this is very straightforward, isn't it? So I want you to take your time and do number 2, and let's see what you're going to come up with. But otherwise, leave your answers in the comments and the method that you employed to solve this one. All right, thank you so much for tuning in today. Until next time, don't forget to like, don't forget to subscribe to the channel. Thank you so much.